Hello everyone, welcome back to my channel Physixopedia. Thanks for watching my videos. Please subscribe to my channel. Leave your comments in the comment box. Please share to your friends if you like the videos. Today our topic is Doppler effect. It is very important topic in the waves chapter, especially in terms of objective point of view. So let us go ahead and discuss about this concept clearly. To analyze this topic, before we are going to analyze this topic, let me give a real life example. Imagine an illustration. Just imagine you are standing in the bus stop or you are standing on the roadside. You've seen a vehicle is approaching to you. When the vehicle is at some X distance in front of you, the vehicle started making sound and the vehicle is coming closer to you, closer. Have you ever observed, is there any difference of sound that you observed? That means the pitch of the sound, have you observed the difference? And as the vehicle is leaving away from you, have you observed the difference of the sound that you observe? Right? There will be a difference of the sound, right? As it is closer to you, you will observe more the intensity. As it is leaving away from you, you observe less intensity, right? Where is the problem? Is there a problem with the source? That is it been producing a different amount of intensities of the sound as it is closer to you? Or is it been producing less amount of the sound as it is going away from you? No. The problem is there is a relative motion between the source and the observer. The source is producing a constant frequency and the constant pitch of the sound. But an observer observes a different amount of the frequency and different amount of the pitch, right? So this effect is called Doppler effect. So let me give you what exactly mean by Doppler effect. Doppler effect is a change in frequency of the sound wave when observer, source and the medium are in relative motion. Once again I am giving you Doppler effect is a change in frequency of sound wave when observer, source and medium are in relative motion. So here as an observer you are at rest, a vehicle is approaching to you, therefore there is a relative motion in between you and this source. So you observe the different intensity of the sound. This effect is called Doppler effect. Let me give you a video or PPT about Doppler effect. I hope it will give you more clarity about it. You understand what exactly mean by Doppler effect after you have seen this PPT, right? So let us go into Doppler effect even more clear, more depth in terms of numerical point of view or in terms of derivation. Let us derive a formula for this, why the Doppler effect is observed in a different frequencies. Let us go into discuss this. Imagine a situation that you are standing, you are the observer standing at a point O. So O is the observer. So he is rest with respect to the medium, the place where he stands. And there is a vehicle. Let us imagine a car. Please don't mind, I am not good in drawing. So the car was initially moving towards to the observer with a velocity Vs. Let me call it as Vs. Vs is nothing but velocity of the source. Here the source is the car. Let me call this point is some A. So the car was initially moving with the velocity Vs and it is coming towards to the observer. At a point A, the car started making sound. When it reaches to a point A, the car started making sound. Okay. So here I will say the time starts now. The time here is 0. The time starts now. And here I wanted to tell you one more point. The sound produced by the car has some velocity in the given medium, right? So velocity of the sound in the given medium, let me consider velocity of the sound in the given medium, let me consider it as V. Where V is the velocity of the sound, Vs is the velocity of the source. Remember this point. And let the initial distance between source and the observer is some x. Let the initial distance between the source and the observer is some x. And one more point I wanted to tell you. So the sound wave produced by the source, the time taken by the sound wave to complete one cycle, let it be some t0. That means the time interval between the two sound waves, let it be t0. The time interval between the two sound waves, let it be t0. Remember this point also. t0 is the time taken between the two sound waves. Now, when the source started making sound from point A, how much time the sound will take to reach an observer who is at x distance? So, we know that velocity of the sound is equals to distance travelled by the sound in time. Let me consider the time taken by the sound to reach from the source to the observer is t1. So remember, now time is t1. Let me consider this as h1. Or I'll write this as, therefore t1 is equal to how much? X by v. I consider this as 1. Where v is the velocity of the sound, x is the initial distance between the source and observer. Remember this point. Now, the first wave reached. What is this? When the next wave will be started? After time t0, right? Where t1 is the time taken by the sound to reach observer, where t0 is the time between the two sound waves. So after time t0, the next sound wave will be started from the source. Here I want you to remember that here the source is not at rest. As the source is moving in the time t0, it would have traveled some more distance. Let me consider it as some x dash distance when it reaches to point B in the time t0, because it started making sound here. The second sound wave will be started after t0 time, right? So in that time the car have already traveled some x dash distance. Now it is at point B, right? So what is this distance x dash value then? The x dash or velocity of the source is equals to distance travelled by the source in time t0. Therefore, x dash is equals to velocity of the source into time taken, right? Here t0 is the time between the two waves. Remember this point once again. Now, the second wave is started from point B. How much time this second wave will take to reach point O? Now, how much time it will take? The second wave, let it be the time is t2. The time taken by the sound wave to reach the observer is t2. Here t2 is time gap between the two waves, t0 plus distance between these two by velocity. Distance between these two is OB is nothing but OA minus AB. OA is nothing but x, AB is nothing but x dash. I can write x minus x dash by velocity of the sound is how much? Do you understand what I mean? The total time taken by the light second wave to reach point B is nothing but time gap between the two waves plus time taken to reach from here to here is x minus x dash by v. This is x minus x dash is the distance between O to B and v is the velocity of the sound. Therefore, what is the time difference between the two sound waves that reach to the point observer O? What is the time difference between them? That is nothing but T2 minus T1. T1 is the time taken by the first wave, T2 is the time taken by the second wave to reach to the observer. Therefore, the apparent or the change of time T2 minus T1 is equals to T0 plus x minus v dash by v is the T2 value minus of T1 is x by v. Therefore, the apparent change in time T2 minus T1 is equals to T0 plus x by v minus, this is x dash, remember, x dash by v minus x by v. So if you observe, plus x by v minus x by v get cancelled, right? So what you got? The apparent change in time T2 minus T1 is equals to T0 minus x dash by v, right? But we know what is the value of x dash. X dash is nothing but Vs into T0. Substitute two value in the given equation. What you will get it? Apparent change in time T2 minus T1 is equals to T0 minus x dash is nothing but Vs into T0 by V. So let us take V0 T0 value common. So apparent change in time T2 minus T1 is equal to T1 to 1 minus Vs by V. Right? Or else you can write T2 minus T1 is equals to T0 into V minus Vs by V. But we know the frequency is equals to 1 by time. Then apparent frequency is equal to 1 by apparent change of time. Real time is equals to 1 by change of frequency. So I can write this as apparent frequency or change in frequency is equals to real frequency of the sound into V by V minus Vs. Because it's reciprocal, I have done it. I hope you understand. So this is what the observer observes. So when the vehicle is approaching to the observer, he observes more than the frequency of the actual. Why? Because here V minus Vs, always remember velocity of the sound is greater than velocity of the source. Then only you can observe the Doppler effect. If the velocity of the source is greater than velocity of the sound, you may not observe the Doppler effect. I'll explain you why in the next video. So as V minus Vs gives the value lesser than 1 something, you will get f dash is more than f, because here numerator value is going down, therefore f dash value will be goes on. That means as the source is approaching to the observer, he observes more the frequency than what actually produced by the source. What if now if the source is leaving him? Now what is the frequency that he observed? As the source is leaving him, the velocity of the source with respect to observer will be considered as negative Vs, right? As the source is leaving the observer, the velocity of the source with respect to the observer will be minus Vs. So I'll write, if source moves away from the observer, if the source moves away from the observer, the velocity of the source with respect to observer will be equals to minus Vs. Now substitute the same value in the given equation. Then the apparent frequency or change in frequency that he observed is equals to F into V by V minus Vs is minus Vs, so plus Vs. As the denominator value increases, the apparent frequency or change in frequency value will goes down, right? So as the vehicle is moving away from the observer, he observed the less frequency than what actually is being produced by the source. I hope you understand what is meant by Doppler effect in terms of even formula way. I hope this lecture is useful to you. If you like the video, please press the like button, subscribe to my channel, leave your comments in the comment box, share to your friends. Thank you.